Hi guys, I trust that you're feeling well and awesome. Welcome to this video on grade 12 mathematics, and in this video we'll be having a look at differential calculus with the subtopic of the equation of the tangent. This is the third video in a series of videos that covers grade 12 mathematics differential calculus. If you have not watched our previous video on the laws of differentiation, I would highly suggest that you have a look at it before you come to this video, as some of the knowledge that you learned in that specific video will be applicable here. So, in this video, we'll be having a look at how to find out exactly what is the tangent of a curve. So we'll be having a look at what the tangent is, how to find the gradient of the tangent to a curve, and then we'll also have a look at how to find the equation of the tangent of a curve. Without any further ado, let's look at it. So, we can define the tangent as a straight line that touches the curve at only one point. Now you might be thinking, okay, hang on, we said a tangent is a line that touches the circle at only one point. That's true. When working with circles, we do have tangents. But when also working with curves, we also have a tangent. Now notice that we said it's a straight line. Straight line implying that it has the equation y equals mx plus c. Please take note of this. We will come back to it. And we said that the tangent touches the curve at one point only. This is different to the scenario that we looked at previously, where we were calculating the average gradient, and we know that the average gradient is between two given points, and in that case it's not a tangent. So, being a straight line, the tangent also has a gradient and a y-intercept. As we've said earlier, that the equation of the tangent is the same equation of a straight line, which is y equals mx plus c. Right. Exactly as we said here, we've got y equals mx plus c. Now, let's talk about how to get the gradient of the tangent. Now, to get the gradient of the tangent to a curve at a specific value x is equals to a, what we do is we find the first derivative of the graph, or we find the first derivative of the curve. Then we substitute x is equals to a into that specific equation. It does not matter what type of curve we're looking at. It could be a quadratic function, a parabola. It could be a hyperbola. It could be any type of polynomial. For as long as we have a curve, we can substitute the x equals to a, or the x value, into the first derivative to get the gradient. Like we've said, to get the gradient of the tangent to a curve at a specific value x is equals to a, all we do is we find the derivative and then we substitute that x value into the derivative. I hope that this makes sense. Let's actually look at an example of how to do this. So the first question says we need to find the gradient of the tangent to f of x equals 2x squared minus x at x is equals to minus 1. So let's have a look at this. We have the equation f of x is equals to 2x squared minus x. We are told that we need to calculate the gradient at x is equals to minus 1. So the first step is we need to find the derivative. If you can remember from our power rule, we said that the derivative of f of x is equals to multiply exponent by coefficient. So 2 times 2, that gives us 4x. Subtract 1 from exponent, that's just 1. We have an exponent of 1 here on the x. 1 times negative 1, that's going to give us negative 1x. Subtract 1 from the exponent, this is going to be x to the power 0. We have our derivative of f as 4x minus 1. We said to calculate the gradient of the tangent, we need to substitute our x value into the equation of the first derivative. So this is going to be 4 into minus 1 minus 1. This is going to give us negative 4 minus 1, which is equals to negative 5. There we have it. Our gradient of the tangent at x is equals to minus 1 is actually negative 5. Life is great. Let's look at the next question. So the next question says we're determining the gradient of the tangent to g of x, which is negative 4 over x at x is equals to 2. So let's have a look at this. We have got g of x is equals to negative 4 over x. We are told we need to get the gradient of the tangent where x is equals to 2. So the first thing we need to do is to find the derivative of g of x. But now we said in our previous video that we cannot find the derivative of a variable being the denominator. We need to take this to the numerator. When we take it to the numerator, we get negative 4x to the power minus 1. Now we can find our derivative. So the derivative of g of x is going to be multiply exponent by coefficient. Negative 4 times negative 1 is going to give us positive 4x. Subtract 1 from exponent, we get negative 2. We can simplify this by writing it as 4 over x squared. And now we can get the value of the first derivative at x is equals to 2. This is 4 over 2 squared, which is just going to give me 4 over 4. The gradient of our tangent is 1. Wonderful. Life is great. Let's have a look at the next question. So in the next question, it says for which values of x does the gradient of the tangent to g of x equals to x minus 1 all squared plus 4 have a gradient of 6. Let's go back to our writing pad and have a look at this one. So in this case, you would notice that we are supposed to solve for x because we do not know what the value of x is. Let's start by writing down our equation first. So you've got g of x is equals to x minus 1 all squared plus 4. We do not know what our x value is, but we are given that the gradient of the tangent at that specific x value is 6. Right, let's see what we can do. Let's think about this for a moment. We said to get the gradient of the tangent, we substitute the x value into the first derivative. We do not have an x value here, but we do have the gradient. In other words, we could substitute the gradient into the first derivative. Let's see. So first, let's break the brackets here. That's going to give us x squared minus 2x plus 1 plus 4, which is going to give us x squared minus 2x plus 5. This is our equation for g of x. Now, the derivative of g of x is going to be multiply exponent by coefficient. This is 2x. Subtract 1 from exponent. This is 1. Multiply exponent by coefficient. This is going to be minus 2x. Subtract 1 from exponent. This is 0. Derivative of 5, which is a constant, we said that is 0. So when we simplify this, we get 2x minus 2. We can substitute our gradient into the first derivative. So 6 is equals to 2x minus 2. What we can do now is we can transpose the minus 2. And we're going to get 6 plus 2 is equals to 2x. 8 is equals to 2x. I can divide by 2 and divide by 2. The 2 cancels the 2. I remain with the value of x as being equals to 4. There we have it. We have answered the question. I hope that this makes sense to you guys. I hope you guys are enjoying the video, that you're benefiting from what we're learning here. If you are enjoying the video, please give us a thumbs up. Please subscribe to the channel. Please click on the bell icon so that you will always receive an update every time we upload a new video. Right, now let's have a look at finding the equation of the tangent to a curve. Now, you remember earlier that we said a tangent is a straight line that touches the curve at only one point. We said to get the gradient of the straight line, we substitute the x value into the first derivative. So in other words, your gradient is equals to the first derivative of a at a specific value x is equals to a. Now that's great and that's wonderful, but the gradient is not enough for us to determine the equation of the line. We can go a step further by determining the equation of the tangent at this specific value. Now how do we do this? Well, if we are given a specific x value, for example, x is equals to a, what we need to do is we need to find f of a. So this is the equivalent of saying substitute x into the original equation for us to get our y value. Then the next step is we need to find the gradient by calculating the first derivative and substituting the x value into the first derivative. Because the tangent is a straight line, we need to use the equation y minus y1 equals m into x minus x1. Then what's going to happen is our y1 will be the y value that we calculated in the first step. X1 is going to be the x value that we are supplied with. Then the gradient would be what we calculated in step 2. Let's have a look at this in a practical sense. So the question says we need to determine the equation of the tangents of the following curves at the specified x values. So the first curve we have is f of x equals to negative 4x cubed minus 2x squared at x is equals to negative 1. So let's see how we would do such. Let's start by getting up a new sheet of paper here. Our equation is f of x is equals to negative 4x cubed minus 2x squared. We are told that we need to find this at x is equals to negative 1. The first thing we need to do is, let's find the gradient of the tangent. So, we need to find the first derivative. And we said, multiply exponent by coefficient. Negative 4 times 3, that's going to give us negative 12x. Subtract 1 from exponent, this is going to be squared. Multiply exponent by coefficient. So, 2 times negative 2 is going to give us negative 4x. Subtract 1, we're just going to get 1 there. So in other words, our equation is negative 12x squared minus 4x. Now, to get the gradient, we need to substitute x equals to negative 1 into the first derivative. So there we have it, we've substituted. We will get negative 12. Let's see, this is going to be plus 4, which is going to give us a gradient of negative 8. Right. Our next step would be to find the y value. So now we are finding y. To get y, we said we substitute the x value into our original equation. So f into minus 1 is going to be in the original equation of f of x. Where I see x, I'm going to substitute negative 1. So this is going to be 4 into negative 1 cubed minus 2 into negative 1 squared. And this would give us something like negative 4 minus 2, which will give us negative 6. We have our x and y value, and we have our gradient. Now we can find the equation of a straight line. We could say y minus y1 equals m into x minus x1. So, by the way, this is going to be our y1. Our x1 is going to be the negative 1 which we are given, and our gradient is going to be the negative 8 which we calculated. So, y minus minus 6 is equals to negative 8 into x minus negative 1. So, y plus 6 is equals to negative 8 into x plus 1. When we get to this stage, we can multiply out the brackets. So y plus 6 is equals to negative 8x minus 8. We can take the positive 6 to the other side. We will get y is equals to negative 8x minus 8 minus 6. And this will give us an equation of y is equals to negative 8x minus 8 minus 6. That's going to give us minus 14. And there we are. We've determined the equation of the tangent. Life is great. Let's look at the next question. So, in our next question, we are finding the the equation of the tangent of g of x equals to negative 3 over x at x is equals to x is equals to 3. Let's have a look at this one. So, let's open up a new sheet of paper just for some more room. We are having here g of x is equals to negative 3 over x. Now, the x value we're given is x is equals to 3. Once again, what we can do is we can first find y. Whether you find the gradient first or you find y first, it doesn't really matter. To get y, we substitute x into the original equation. This is going to be negative 3 over 3, which is going to give us negative 1. This is going to be our y1. This is our x1. The next step is for us to find the gradient. So, before we write down the first derivative, let's just write the original equation first. Then what we do is we need to take our x to the top because we cannot work with x being a denominator. This is going to give us negative 3x to the power minus 1. Now, we need to find the derivative here. This is going to give us multiply exponent by coefficient. So, negative 1 times negative 3 gives us positive 3x. Subtract 1 from exponent, this is minus 2. We can write this as 3 over x squared. The next step is I need to substitute x is equals to 3 into my first derivative. This is 3 over 3 squared, which is just going to give me 3 over 9, which is 1 over 3. This is my gradient. Now I can find the equation of the tangent. I can say y minus y1 is equals to m into x minus x1. So, y minus our y1, we got it as minus 1. So, minus 1 is equals to our gradient of 1 over 3 into x minus x1. Our original x value was x is equals to 3. So I just substitute 3 there. Now we multiply out the brackets. This is y plus 1, giving us 1 over 3 into, let's multiply out the brackets. This is x, and then 1 over 3 times minus 3 just gives us minus 1. We could take the positive 1 over, and we get y is equals to 1 over 3x minus 1 minus 1, which is going to give us y is 1 over 3x minus 2. There we have it. We have determined the equation of the tangent. Brilliant. Life is great. And let's look at the next question. The next question says we're still finding the equation of the tangent to the curve h of x equals 2 into x minus 4 all squared at the value x is equals to 4. Let's have a look at this one. Once again, let's open a new sheet of paper. And the equation that we were given was h of x is equals to 2 into x minus 4. Is it minus 4? Yes. Squared. And the x value that we were given here is x is equals to 4. First thing we need to do is, let's first find the value of y. We find the value of y by substituting x is equals to 4 into the original equation. This is going to give us 2 into x minus 4 squared, which is the same as 2 into 4 minus 4 squared. That's going to give us 2 into 0, which is just 0. This is our y1. The next step is we need to find the derivative. We need to find the gradient by finding the derivative. So we are given h of x is equals to 2 into x minus 4 all squared. Before we can find our derivative, we need to multiply out the brackets. This is going to give us 2 into x squared minus 8x plus 16. If I multiply out the brackets, this is going to be 2x squared minus 16x plus 32. Now, we need to find the derivative. So the derivative of h of x is equals to multiply exponent by coefficient. 2 times 2 gives us 4x. Subtract 1 from exponent, that's just exponent 1. We have a 1 here. Multiply exponent by coefficient, that's going to give us negative 16. Subtract 1 from exponent, this is x to the power 0. Derivative of a constant is 0, so there we are. Now we can proceed. This is 4x minus 16. By the way, our x value is 4, so let's substitute that. So our first derivative at 4 is equals to 4 into 4 minus 16. You would see that this gives you 16 minus 16, which is equals to 0. Wow, we have a gradient of 0. We have a y value of 0. So this should tell you that because our gradient is 0, remember that the 0 gradient means that we have a horizontal line. Now, where is this horizontal line? Notice that our y value is 0, our y coordinate. So this basically means that when we had to attempt to find the equation by using y minus y1 is equals to m into x minus x1, you will see that we have a little bit of a problem here. We're going to have y minus 0 is equals to our gradient of 0 into x minus 0, which is just going to give you y is equals to 0. Now, y is equals to 0 is a horizontal line. This is actually the x-axis. Nevertheless, it is still a tangent because if you think about it, the graph that we're looking at here has a turning point of 0 and 4. Since the turning point is on the x-axis, it therefore implies that the tangent will also be at the x-axis at the specific point, the turning point. I hope it makes sense to you guys, and I hope that you understand this video, that you found it useful, that you find the content productive. If you do, please give us a like, give us a thumbs up, please subscribe to the channel, click on the bell icon so that every time when we upload a new video you get an update. Also, please don't be selfish, please share the video with other people so that everybody can be benefiting from the knowledge that you are learning. Until then, have a blessed day. Ciao.